Hello friends, welcome to my channel. In this video I'm going to explain 12th standard physics photometry chapter. The contents that all we are going to learn in this chapter is important definitions, relation between luminous intensity and illuminance, and Lambert's cosine law of illuminance, and photometer and principle of photometry. These are the important things that we are going to learn in this photometry chapter. Next, first important definitions. The important definitions in this chapter is photometry. What is photometry? It is the branch of optics. It is a branch of optics which deals with the study and measurement of the length of the light. Length of the light study. It is a photometry. It belongs to a optics where we study about how the study and measurement of the light energy. Next important formula is solid angle. The area of spherical surfaces subtends an angle at the center of the sphere. This angle is called solid W. The area of a spherical surface subtends an angle at the center of the sphere. The area if a spherical surface its area, it subtends an angle at the center of the surface, center of the sphere. It subtends an angle. This angle is known as the solid. Now first one, the for solid angle is equal to area of delta A by r square. Its unit is radian. Solid angle subtended by the whole sphere at its center is 4 pi, or 4 pi is the radius. 4 pi is the radius. Next is radiant flux. The total energy radiated by a source per second is called radiant flux. The energy, how much energy radiated from source, how much energy we get for per second, per second, how much energy we get from the source, that is energy is known as the radiant flux. It is the SI unit is watt. Next, luminance flux. The total light energy emitted by a source per second. The total light energy that is emitted by a source per second. The energy emitted by light for each second is called as the luminous flux. That is represented in the SI unit is lumen. Luminous efficiency. The ratio of luminous flux and radiant flux is called as the luminous efficiency. It is the ratio of luminous flux and the radiant flux. Next, light source. Here, light source 40 watt tungsten bulb. Flux lumen is 465. Efficiency lumen watt is 12. 60 watt tungsten bulb for 835 is the flux lumen. Efficiency is 14. And 500 watt tungsten bulb, 9950 is the flux flux that is lumen, and efficiency is 20 lumen watt. 30 watt fluorescent tube, flux lumen is 1500 and the efficiency lumen watt is 50. Next, luminous intensity. It is the given direction. It is defined as luminous flux per unit solid angle. Luminous intensity in a given direction. In the given direction, it is defined as luminous flux per unit solid angle. That is, L is equal to light energy by second into solid angle. That is, lumen by steradian. That is equal to candela. Okay. Next is illuminance or intensity of illumination. The luminous flux incident per unit area of a surface is called illuminance. The luminous flux that is incident per unit area of a surface is known as the illuminance. Unit of SI unit is equal is minus lumen by m square, or lux. Intensity of illumination at a distance r from, like this, from points and line sources. Then is difference between illuminance and illumina of a surface. Illuminance, it represents the luminous flux incident on unit area of the surface, while luminance represents the luminous flux reflected from the unit area of the surface. So luminance, it represents the luminous flux incident on a unit area of a surface, while luminance represents the luminous flux reflected from a unit area of that surface. A relationship between luminous intensity and illumina is, if S is a unidirectional point source of the light of luminous intensity L, and there is a surface at the distance r from the source on which the light is falling normally. So this is the diagram you can see. So here S is a unidirectional point source of light illuminates L, and there is a surface distance at a distance r from source to distance, it is r, on which light is falling normally. Illuminance of the surface is given by I is equal to L by R square. So I is equal to L by R square is the illuminance of surface is given. For a given source, L is equal to constant. So I equal to I by R square. So this is called, so inverse square law of illuminance. So this I infinity I by R square is called as the inverse square law of illuminance. Next is Lambert's cosine law of luminance. So in the above discussion, if surface is so oriented that light from the source falls on it obliquely, and the central ray of light make an angle of theta with the normal to the surface, then, so in the above discussion, if a surface is so oriented that light from the source the light falls on the obligated, and the central ray of the light makes an angle of theta with the normal to the surface, from normal to the surface, then illuminance of the surface I is equal to uh, L cos theta by R square. And if for a given light source and point of illumination I 100 cos theta, this is the called as the Lambert's cosine law of illuminance, where I max is equal to L by R square, that is equal to I naught at theta is equal to 0 degree. Now for a given source and plane of illuminant cos, so this is the formula cos theta h by r, so I is equal to h by L by h square cos cube theta, or I is equal to L into h by r cube, as I into cos cube theta, or I into I by r cube. Now final concept of this photometry chapter is photometer and principle of photometry. So photometer is a device that is used to compare the illumination of two sources. It is a photometer. It is photometer. It is a device that is used to compare the illumination of two sources. The sources of luminous intensity L1 and L2 are placed at a distance R1 and R2. So two sources are placed L1 and L2. It is placed at some distance, that is R1 and R2, from the screen, so that their flux are perpendicular to the screen. So from the screen, so that the flux, it will be perpendicular to the screen. The distance R1 and R2 are adjusted till I1 is equal to I2. So the distance R1 and R2 are adjusted till I1 and I2. So L1 by R1 square is equal to L2 by R2 square, gives L1 by L2, that is equal to R1 by R2 whole square. So this is the called as the principle of photometry. This is the principle of photometry. So okay friends, this was your chapter of photometry. So all the concepts, four concepts that were formulas, solid angles, many other formula, luminous, many other formula I have explained. And I also explained the relationship between luminous intensity and illumina, and also I explained Lambert's cosine law of illuminance, and also photometry and principles of photometry. So okay friends, I'll see you in my next video by explaining some other topics of your 12th. So till then, take care, have a nice day, bye my dear friends.